Okay, so we're going to talk today about APIs for inhalation, and then a little bit about inhalation in general. I will discuss in this session the basics, a bit about the respiratory systems, the micronization process, and the special regulatory requirements. So first of all, this segment of dry powder inhalers and metered dose inhaler is quite new. Until the beginning of the 2000s, this was actually a simple dose form, because then we had CFC. CFC, which is, as the freon gas, was both a very good propellant and also a good solvent. So basically all the anti-asthma drugs were simply dissolved in the freon, and then you would inhale them, they would go into the body as a solution, the gas would evaporate, and the particles would settle in. It was safe, it was very efficient, but because of the ecology aspect, of course, freon gas was banned from use. And from 1996 until more or less 2010, all the industry had to switch to others. And the two inhalers today on the market are the dry powder inhalers, which are using dry powder directly into the body, and the metered dose inhalers that use not the CFC gas, but the HFA gas, hydrofluoroalkyne, which is a good propellant, but it's not a good solvent. And this is why most of these inhalers are in suspension. And then again, the powder is there and it needs to be micronized. What you will see in the specifications for these products, first of all, very small particles with very narrow distribution, and usually the DO5 will be between 1 and 3 microns, which is extremely small. The specification will be very tight. You will see crazy specification like from 1.2 to 2.6 microns, and you will ask yourself, how did they get to this specification? You will see additional quality attributes, crystallinity, surface area, maybe in microscope pictures, a certain morphology, and so on. We will see later where does it come from, and why are these aspects included inside the specifications. What you need to remember is that in those forms, the quality of the API is the quality of the therapy. In these inhalers, you have probably something like API and maybe lactose, and that's it. So the API you provide to the formulator is the quality of his product. I think most of you, since I know you are involved in micronization and API, do we have anyone that is involved in formulation of inhalers or micronization for a third party? Okay, so I will address this session as if all of you are micronizing APIs. If anyone has specific question about inhalation or is doing a formulation, please let me know. So first about the respiratory system. On the left you see, by the way, do you see my mouse? I'll take that as a yes. You see here the respiratory system. We have the larynx, which is the mouth. By the way, these are the sinuses. So if you are catching cold and you have headaches, this is because the sinuses, which are voids in the skull, are getting inflamed. And this is why for catching cold, you have the headache here and here. I just learned that recently. This is the pharynx. It's like a tube that goes down, then it gets split to the two trachea. Again, it starts to split again and again to the bronchial and to the lungs, and in the lungs we have the very narrow passage and the alveoli where the blood and the oxygen are being exchanged. We are not doctors, we are engineers, so let's look at this as simply a series of vessels and tubes. So what we have is the nasal airway, the mouth, and the pharynx, and the trachea. Until now, we have one. Okay, this is one tube. the diameter of the trachea is 18 millimeter. Then it gets split into two main bronchi, this one and this one, which are 13 millimeter in diameter. And then it starts to split and split. You see already we have 500 bronchioles and more and more and more and more and more until you go down to the alveoli. Now look at the diameter. Until here we are in the range of millimeters. And down to the very final bronchioles, which are these ones, we go down to less than 1 millimeter. Now, as a rule of thumb, if you have powders flowing in a tube, you need the powder, the particles to be at least 6 to 10 times narrower than the tube in order to avoid blockages, mechanical blockages. Okay? If you enter 2 particles into a tube and they are less than that, or you are more likely, more than that, then more likely you are going to get a blockage. So just from looking at the mechanical aspects, you can start to imagine why, when we look at these final terminals, we need the particles to be about 1 to 3 microns. Okay, this is where it comes from. Wherever the typical air velocity that goes, you see in the beginning the speed is quite high, and as we go down, we go to a laminar flow, which is very slow. And the residence time is very, very short in the beginning, and only here in the alveoli you have a few seconds of residence time. This is where the blood and the oxygen are being exchanged. What you need to remember is that while our GI tract, our ingestion system is built for absorbing materials, our entire respiratory system is built to avoid absorbing particles and dust, because this respiratory system needs only gas. So the entire system is built to push out any particles, and people who are doing respiratory products need to overcome these limitations. So our body have many clearance mechanisms, and let's see what happens to particles that goes into the body. If it gets stuck in the oropharynx, then, just a second. If we go into the oropharynx, then you'll get particles being impacted. If they stop there, they will simply stuck on the back of the throat. This is when we'll feel this powdery feeling. It will be intercepted and maybe electrostatic attached to the mouth. The clearance is by mucus, which is coughing, sneezing, spitting, and this is how the body is expelling. And everything that is under above 20 microns will never pass your mouth. Okay, it will get stick in the mouth and you will spit it out or cough it out. If the particles are smaller than 10 microns, then they will start going into the tracheobronchial and being intercepted or sedimented, which means that they will settle to the bottom of the body. The body have two mechanisms to clear these: coughing, which is intermediate, or by the mucus that slowly starts to migrate up and takes hours to clear. Remember, we want to get the drugs into the body, so we want them to stay there several hours, and this is why we need to get them into the pulmonary area, where particles are already going by diffusion, because this is a laminar flow. They will sediment to the bottom and will intercept in the tubes. Particles that go into the pulmonary don't go out, okay? They have two ways to clear. One of them, they simply dissolve. And if they don't dissolve, there is something called phagocytosis, which means that the body builds a tissue around them and they simply stay there forever. This is how you get all kind of infection, and this is how actually people who smoke get their lung disease. So particles under 3 microns will go all the way to the pulmonary system, to the lungs.